Hello everyone, myself Aryan Singh. I am a member of Team Tech Cerberus. The product we are going to display is an ornithopter, which is a type of flying aircraft designed in the shape of a bird, as you can see in front of your screen. So these are the contents we are going to follow in this session. Now about us, we are Group Tech Cerberus. We provide logical solutions in tech world for modern world problems. In this particular session, we are going to elaborate the necessities and all queries related to an ornithopter device in today's world. So here is a quick introduction of our team members. Firstly, here is Arsh Sood. He is the assembler and test engineer. Then myself Aryan Singh. I am maintenance specialist and systems engineer. He is Adarsh Khanna. He is the programming head and product designer. So this is the product description. Our mission is developing an ornithopter device which looks like this in the shape of a bird. It is a form of an aircraft known as an ornithopter, flies by flapping its wings, much like birds and other insects do. Due to their distinctive flying abilities and their capacity to replace conventional drone, used in sensitive fields like defense and public surveillance in urgent situations, which with specific solutions. They have recently gained more popularity in the field of robotics. So, what is the vision of ornithopter? Let's uh, study this. Ornithopters, which can be designed to look like birds or insects, could be employed for military purposes such as air surveillance without letting the enemy know they are being watched. Video cameras have been mounted on a number of ornithopters, like generally this tradition is followed in the industry. Further applications of ornithopters, they can be used to scare away birds that could damage the engines of birds in case of bird strikes. Used for forestry and wildlife survey. They can be used for traffic monitoring, and this is the this is the application in real life which was being done in some international airports. You can read them. So, what are the problem domains? The increased effectiveness by utilizing the natural lift produced by flapping wings. Ornithopters have the potential to be more effective than conventional fixed wing aircraft. This might result in the less fuel use and pollution, which is quite concerning for the aviation sector. Next comes the portability. Ornithopters may be more mobile than conventional aircraft, which might make them suitable for missions like military operations and surveillance and search and rescue missions. Quiet flight. Ornithopters may be able to fly more quietly than conventional aircraft, which may be advantageous for activities like observing wildlife and conducting scientific research. So, these are some current industry solutions and their challenges. Some solutions can be there can be a combination of modern materials, complex control algorithms, and advanced production techniques are currently used in industry to create ornithopters. Making an ornithopter that is effective and controlled, even with these technologies, it is still difficult task. So there was a British team that has developed a new miniature flying robot that flaps its wings like an insect with no conventional motors and gears. It's a step towards flapping sorry, step toward flapping flight that's more like the way animals do. Nature, of course, uses flapping wings on everything from mosquitoes to any other flying creature. Humans have had more success building flying machines that use propellers, rockets, and jets, and other flying man made objects. So, what are some challenges? There is a strict need in the market for an innovative solution that can address the difficulties of developing successful ornithopter. Projects involving robotics can help with these. It's really been an uphill battle, said some UA communication senior Brett Baker. This was his name. It was crash after crash with every little positive feedback to make you continue. What he described, we have deeply elaborated in the below lines. You can go through them and have deep knowledge. So, what are some identifying gaps and opportunities in this world regarding these type of electronic devices? Our robotics research intends to develop a novel control system that employs cutting edge sensors and machine learning algorithms to enable real time modifications to the wing flapping action in order to tackle the difficulty of constructing and commanding an effective controllable ornithopter. We think that we can develop we our team we think we can develop an ornithopter that is capable of sustained controlled flying in a variety of locations and situations by utilizing the power of machine learning. Now, what is the operating theory? Let's discuss this. In conclusion, ornithopters pose a special challenge for robotics since they necessitate complicated interaction between aerodynamics, mechanics, and control. Modern manufacturing techniques, complex control algorithms, and advanced materials are used in the industry to create ornithopters. But even with these advancements, it's a sorry, it is still difficult to build an effective controlled ornithopter. By creating a novel control system that makes use of cutting edge sensors and machine learning algorithms to enable real time modifications to the flapping motion of the wings, our robotics research hopes, yes, it hopes to solve these difficulties to a good extent. We think that this strategy has a lot of potential for the use of ornithopters in robotics in the future. So, thanks for watching and thank you from Teams Tech Cerberus.